All right, folks. So we're going to talk about just a little bit about exponents real quick. Just want to motivate this conversation. Exponents, remember, I'll explain exactly what they are in a minute. Just it's a number that's multiplied over and over again is sort of the way we understood it previously with that little number written up top. We're going to go into a lot of the rules around that. It's really an eighth grade thing. But I do want you to see that it is something that you might think is not that useful. And it's not useful. It's not like you're going to use it every day in your life, but understanding it is crucial to how you understand how the world works, right? So one thing to see right here is if you save money, it grows exponentially because you start with a little bit when you put money away, and then that grows to be worth a little bit more when you invest it. And then that new amount is now going to grow again by that same rate. And you kind of can think of it as like that old story of, I don't know if you've ever heard the story of the peasant who asked the king for, 1 grain of rice today and then double it tomorrow. So tomorrow, just give me 2 grains of rice. And on the third day, give me 4 grains of rice. And on the fourth day, give me 8 grains of rice and give me times 2 every time, right? And says, just do that for a month. And that's all you have to pay me. And the king was like, yeah, no problem. That doesn't seem like a big deal. And of course, by the end of 30 days, if you keep on double, double, double times 2 times 2 times 2 times 2, the king had to give all the kingdom's rice to this, person. So it's the sense of the amount you have each day. If that grows by a certain amount again, it gets more and more. So this is a savings one. Hold on one second. Here we go. You can have things decreasing also exponentially. So this is when you have a fraction multiplying over and over again. It gets smaller and smaller and smaller very quickly. And this is something called decay. This happens with radioactive stuff. So radioactive things have a decay, what's called a half-life, and they decay. One second, just trying to make this smaller. Oops, man, not easy. Here we go. Bacterial growth, right? So a lot of microorganisms, coronavirus. One of the issues that we have with all this is that certain things are exponential. The more people who are sick, the more people can infect more people. And the more people are sick, the more people infect more people. Same thing with funguses and how, there's always a little bit of, sorry to gross you out, fungus, bacteria, and everything on your food. But it's not really an issue because your body normally just has these things around and can process them. But if there's too much, it creates these big colonies, then you don't want to eat that food anymore, and it can make you sick, right? So those things also grow fast over time, and that's why we refrigerate things, right? So that we slow the growth rate, which is still exponential, but you can literally bring it way down and bring the growth rate way down. So then there's just human population. So this is the human population of planet Earth growing over time, and you can see it has that sharp gain at the end. So these are exponents. Just for today, all I want to tell you about is just some vocabulary. So if I use the word base, that's the number that's being repeatedly multiplied. And the exponent in England, they call it the index, tells you how many times. We've done this before, okay? The only thing I want to take with that and go a little bit beyond what we've done before is to talk about, so in this case, we have 2 to the 4th power equals 2 times 2 times 2 times 2, right? And then, therefore, 2 to the 3rd power would just be 2 times 2 times 2. 2 to the 2nd power would equal 2 times 2, times right there. And then 2 to the 1st power would equal just a 2. Okay, so you can see that this is fine. Where we're going in 8th grade is to look a little deeper at what happens if we keep this pattern going. So the first one, I believe, is 16. It says over here on the slide. 2 times 2 times 2 is 4 times 2 is 8. So that's equal to 8. This one equals 2 times 2 is 4. And 2 to the 1st power, therefore, equals 2. But if you look at the pattern here, let me use a better pen here, see if I can get that better looking. If you look at how we go from here to here and here to here and here to here, I bet you could predict the next number. So if you go from 16 to 8, then from 8 to 4, then to 4 to 2, what's happening? It's half as much, right? You're dividing by 2 or taking half. So at each step, we go down in exponents, we divide by 2. So what's 2 divided by 2? And the answer is, the answer is 1. So what did we just learn? We just learned that if we go down by the exponent 1 every time, the answer, the next number should be, well, 4, 3, 2, 1. The next number here should be 0. So 2 to the 0 power equals 1. And this is a weird thing. You might be like, huh? Where did that 1 come from? Well, it comes from the pattern, but it also is just an interesting thing to know. And we can go from this into negative exponents as well. We'll get there soon. You might be able to guess what 2 to the negative 1 power would be using this pattern. So that's something we'll look at later, all right? But this is just a little brief introduction. Try the 3 exercises. I think you'll be able to handle them pretty easy. You might want a calculator. It'll make it go faster, okay? Good luck. Let me know if you have any questions. Take care.